As many of you have noted, one of the most common uses for servers today is this idea of hosting servers in the cloud. AWS, Azure from Microsoft, and several other companies have started to host servers or allow you to spin up instances of virtual machines in the cloud. And what I want you to understand is that the low level of that, the background of that, is really physical servers, just like we're studying here, running hypervisors that allow you to interact with that physical environment with virtual machines. So I want to talk a little bit about what does it take to design a specific physical system for running virtual machines, or what operating system do we need to include for running virtual machines? Because virtual machines are really becoming the future of all hardware. Even companies that have single server environments are oftentimes virtualizing that one server on physical hardware in their office, so that if they need to move it to a new piece of physical hardware or add another virtual machine, they can reconfigure those virtual machines significantly easier than if it was actually a physical install of that operating system. So the first thing that we need to think about is, what is the hardware required to run virtual machines? Well, good news, virtual machines can run on almost any hardware. But of course, there is better hardware specifically for virtualization. And the first thing is cores. Lots of cores. Virtual machines like to have access to their own cores. Now, while virtual machines can share cores, imagine the added latency of having to wait for CPU time for a particular task and trying to divvy up that CPU time between two different virtual machines. It will slow both of those virtual machines down significantly. So ideally, if you can essentially isolate or reserve a core or a set of cores per virtual machine, you'll get significantly better performance. So if you're planning on running 4 virtual machines, each of them using 2 CPUs, make sure you've got 8 physical cores. Now, it's important to note here, many Intel CPUs and AMD CPUs have some form of hyperthreading or symmetric multi-threading. Virtual machines currently do not like hyperthreads or those symmetric multi-threads. They really like real cores. And that's because, as virtual machines, they believe that they have real cores. And now hyperthreads and symmetric multi-threads are really neat. They are not as capable as full-fledged cores. An operating system that understands that will actually change which tasks are sent to hyperthreads versus physical cores. However, the virtual machine has no way to know what's a hyperthread and what's a real core, because the hypervisor acts as a layer of abstraction between those two. So if you want the best performance, disable hyperthreading or symmetric multi-threading so that those virtual machines have access to real physical cores. Memory is going to become another significant piece. Again, if I'm trying to run 4 virtual machines and I want to give each of those virtual machines 8 gigs of memory, I'm going to need 32 gigabytes of memory total. Obviously, the more memory I have, the better. But of course, memory is also expensive, so we need to strike that balance between spending too much money on memory and making sure we have enough memory. Now, it is possible, just like sharing cores, virtual machines can share memory, and we call this dynamic memory. So if we have 4 virtual machines, each configured with 8 gigabytes of memory, but we only have 16 gigabytes of real memory in the system, we can share that 16 gigabytes between all 4 of those virtual machines. The problem comes in when those virtual machines try and use all of their allocated memory at the same time. Obviously, 16 gigabytes is not going to hold 32 gigabytes of memory. And you may remember from your hardware class that when a computer runs out of actual memory space, it starts to use the hard drive as memory, what we call swap file storage or page file storage in Windows. And it's going to start moving things out of memory that it doesn't think that it needs into the hard drive. And if you can imagine 16 gigabytes of data trying to push out of memory onto the hard drive and then back from the hard drive into memory as it's called for, you will realize very quickly that the performance is going to degrade significantly. So avoid oversubscribing memory whenever you can, but realize it is an option if you must have more virtual machines or allocate more memory than the system actually has. As far as storage is concerned, it's going to be the most significant bottleneck to a virtual machine environment. Most operating systems are written with the assumption that they have access to the hard drive that the operating system is stored on. And so they will frequently make small input-output operations to that particular drive. Because of this, all operating systems cause very high disk I/O. Now, while the throughput is very small, the amount of data moving back and forth is very small, each one of those operations takes an amount of time. And nobody else can use that disk, or no other virtual machines can use that disk while that operation is going on. Because of this, oftentimes when we have RAID arrays, for example, a 4-drive RAID 10 array, we'll see degraded performance when we have 3 or 4 virtual machines, because all of those virtual machines are making small calls to those RAID arrays, causing it to be active 100% of the time. This can be improved with a high-quality RAID card that has some level of memory cache built in. That cache will absorb several of those small read writes and then write them out to disk as time allows. But it will keep the responsiveness very high for those particular operating systems. Regardless, it's very important to make sure that you have high-performance storage available to those virtual machines in order for them to perform as well as you're expecting them to perform. Another potential solution is to create individual RAID arrays for each virtual machine. However, this becomes significantly difficult to manage if you don't know what the exact virtual machine layout is going to be, or you want to change that later. Lastly, let's talk about networking. Now, a really cool feature of most hypervisors is a built-in virtual switch, which means that one Ethernet port on the backside of the computer can actually be shared between all of the virtual machines inside that computer via that virtual switch. It also means that you can connect virtual machines to other virtual machines without any external connections at all. We'll look into that a little bit more in the networking unit. Now, once we have our hardware in place, as we start to think about making or creating virtual machines on that hardware, we need to start thinking about what that OS or what that virtual machine is going to need. First of all, we're going to start thinking about CPUs. Do we need 1 core, 2 cores, 4 cores? Now realize that we can modify the settings of a virtual machine fairly easily after the fact, but it's best practice to give the virtual machine the most resources that it can have without impacting other virtual machines negatively. Similarly, we'll want to allocate memory for that virtual machine. Make sure that we have enough and make sure that the operating system is happy with the quantity of memory that we have. When it comes to system storage, we have a lot of decisions to make. First of all, where are we actually storing the operating system? Do we have different volumes for the operating system and the data, or is it all stored together? One of the neatest things about storage in a virtual machine is thin provisioning, which just like are allocating more memory than the physical system actually has, we can do the same with disk storage. For example, if my computer only has a 1 terabyte hard drive, I can create 8 virtual machines that each have 1 terabyte of storage. And as long as the combined usage between all of those virtual machines doesn't exceed 1 terabyte, that's fine. And since disk space fills up significantly slower than memory space, allocating or thin provisioning hard drive space makes a lot of sense. Oftentimes we don't know how large the files on a particular virtual machine will grow, or which services will be added, or what data will be stored there. So thin provisioning prevents us from having to reconfigure drives in the future. Once we have a virtual machine configured from a hardware standpoint and we've installed an operating system on it, it's important to make sure that we install what are called the virtual machine tools, or the VM tools, a special set of software that essentially lets the operating system know that it is a virtual machine and should act as such. This will also enhance support for keyboards, mice, or graphics inside of that particular virtual machine. So to summarize, from a hardware standpoint, we want to make sure that we maximize our cores, our memory efficiency, and minimize our hard drive latency using SSDs or low latency hard drives. A high quality RAID card can also significantly improve the responsiveness and performance of those virtual machines. When we configure individual virtual machines, we want to make sure that we allocate sufficient resources for them without encroaching on the resources of other virtual machines.